Dispersion is the property by which light is spread out according to its color as it passes through an object. So first we're going to place the light bulb in front of the mirror, and as you can see, the way mirrors work, the light is reflected off of the light bulb and then onto the mirror. Since the mirror is flat, it reflects the exact image, so we can see the light bulb, and that's all we see. We're going to place mirror 2 in front of mirror 1, and in the reflection you can see both mirrors, and the mirrors are reflecting each other's images, so you can see 3 or 4 mirrors. And now for the last step, I'm going to use this mirage machine, and it's really, it's basically 2 mirrors, curved mirrors, so the light is going to be reflected differently. So put one on top of the other, and then now I'm going to put the light bulb, which is our object, inside. Now it appears like the light bulb is right on top. You can see right there, but it actually isn't. You can't feel it, you can't touch it. It's in a different place inside of it. So that's how the mirage is created. The image is shown or appears to be somewhere else than it actually is because of the bending of the light in the mirrors and how it's reflected off of the mirrors.
Today, for my experiment on light dispersion and scattering, we will be using 1.75 milliliters of water and 75 milliliters of pine sol. And we mix them together. As you can see, when it's displayed by itself, just water, it's all white, and you can see a few rainbows forming. But we pour in the pine sol, and see everything's mixing in together. And if you look at the water from a different angle, you can see that it's clearly turning blue and a slightish green as you look through the glass. And on the paper you can see the rainbows forming around the center line of yellow, which came from the pine sol. And there's rainbows forming all around through the center. This is because as you look through the glass, things look differently. The reflection that reflects off of the pine sol, which is originally yellow, when it mixes with the water, is reflecting back as blue because of scattering and dispersion.
When sunlight reaches the Earth's atmosphere, the gas and particles in the air scatter the light in different directions. Blue light waves are shorter than red light waves. Blue light is scattered in every direction by small air molecules in the atmosphere of Earth. This is called dispersion. Because blue light travels with shorter and smaller waves, it is scattered more than any of the other colors of the rainbow. Therefore, we see a blue sky most of the time. I have this glass here filled with water, and I'm going to shine a flashlight beam through the glass. You'll notice that the light beam shines through the glass and reflects onto the white board I have here, and the beam appears bluish white like the sky. So you can see it's white over here, blue-white. Now, why do you think that sunsets appear red? If it's still a sky, why isn't it blue? So to demonstrate this, I'm going to add some skim milk to the water. Now that I've added the skim milk to the water, you'll see that the flashlight beam still shines through the liquid, but this time it appears more red and orange. So in this experiment, the flashlight represented the sun's rays, and the water and milk mixture represent the molecules of gas in the atmosphere. When these molecules scatter during the day, we have our blue skies. However, when the sun is setting, the blue molecules are so scattered that the red molecules are more visible. Dispersion makes it possible for us to have a pretty blue sky during the day, but also allows us to have the beautifully colored sunsets we see in the evening.
After it rains and the sun comes out, what do you see in the sky? A rainbow. Well, today we're going to make a rainbow. A rainbow is usually seen as a circular arc in the sky. Someone on the ground looks at a half circle. People who have seen a rainbow from an airplane in the sky may know that a rainbow can actually be a full circle. People on the ground only see the top half of the circle, since the bottom half of the circular arc isn't visible from the ground because water droplets can't form on the ground. So if you guys look over here, you can see that there is a cup with some water in it, and on one side there's a blank screen on it, on the other side there's a flashlight. When we shine the light through the cup, it makes a rainbow on the screen. This happens because rainbows form when there are water droplets in the sky, like when it rains. The light makes a path in which light shines into the droplet, and on the inside, the light reflects, kind of like in a mirror, and then shines out of the droplet. The light ray that shines into the droplet bends downward towards someone looking up from the Earth's surface.